So, classified MCQs, the for topic 4.1, which is about simple phenomena of magnetism. You can use chat, mic, or screen annotation to answer. The diagram shows three different metal rods P, Q, R, and S inside coils of wire. Small iron nails are placed on a wooden bench under the rod. The diagram 1 shows a situation when the electric current in the wire, and the diagram 2 shows the situation when the current is switched off. The question is, which row correctly identify the metal rods? Look, when there is a current, because in the first diagram there is a current. When there is a current, it is not attracting the iron nail. When there is no current, it is not attracting the iron nail. So means P is a non-magnetic material. So P is a non-magnetic material. So which can be a non-magnetic material? Copper is a non-magnetic. So either A can be an answer or D. Then what about Q? When we were passing the current, the nails were attracted, and once the supply is switched off, the nails fall apart. So what it shows that the Q is being demagnetized, or it loses magnetic properties, or it is acting like a temporary magnet. So means the temporary magnetic material, that's a soft iron. So that's why Q will be the soft iron. And when we were passing the current, R is being attracting the iron nails. And once the electricity is cut off, still the iron nails are being attracted. It means it remains magnetized for a longer period of a time, or it is a hard magnetic material. So which is a hard magnetic material? Steel is a hard magnetic material. So hard magnetic material remain magnetized for a longer duration of a time. Example, steel. And soft magnetic materials magnetize easily but lose its magnetic property as well easily. That's why Q is a soft iron and P is a non-magnetic material. So it can be copper, aluminium, any other material which is not magnetic. So option A is the valid answer for this. Is it clear? The reason why A is the right answer? Any doubt in this?
No, sir, clear.
Okay. In question 2, three cores of a different metals P, Q, and R are placed inside identical coil. At least one of the metals is a non-magnetic. The cores are held above in some iron nail. The three diagrams are there. A similar question. Which core are magnetic? So first, see, for P, when we were passing the current, the nails are not attracted. When the current is cut off, the power cut off, there is no current, still the nails are not attracted. So means P is a non-magnetic material. But when we are passing the current through Q, it behaves like a magnet and attract the iron nails. And once the electricity cut off, it the demagnetized. So means this is a magnetic material. This is a soft magnetic material, but it is a magnetic. For R, when we are passing the current, the nails are attracted. When the current is cut off, the nails still remain intact. So it's a magnetic material. It's a hard magnetic. So Q is a magnetic. R is also a magnetic. Q is a soft magnetic, where R is a hard magnetic. But both are magnetic. That's why option D is the right answer. They did not ask which is a hard or a soft magnetic. They only asked magnetic. So even hard or a soft, both are magnetic materials. The diagram 1 shows a small compass needle. When its poles marked, it is not near any magnetic material. The diagram 2 shows a bar magnet with the poles marked and the compass is placed. So which diagram, in which direction will the north pole of a compass needle will point? When we draw the direction of a magnetic field, the direction of a magnetic field is always from north to south. So when we draw the magnetic field lines, this is how we draw. So the magnetic field line shows the direction of a magnetic field. So how the compass will point when we place a compass? It will point in this manner. So at point P, how the compass needle will point? It will point towards the right hand side. So B will be the right answer. If you place a compass needle here at near the south pole, so how it will point? Because the magnetic field is into the south. So how the compass needle will point? If we place near the south, so it will point towards the left hand side. If you place a compass needle near the north, so how the compass needle will point? It will point outwards. In question 4, two soft iron pins are suspended from the poles. Which diagram shows how the pins are deflecting? Look, what will happen? Always the induced magnetism happen or occur. So why the C is the right answer? If this is a south pole is there, so this will be north, this will be south, and this will be north, and this will be south. And like poles, what the like poles will do, the like poles will repel. So they push each other. So when they push each other, the south will move away from the south. So as a result, the spacing between the pins will increase. That's why C is the right answer. Even if we change the pole, it won't make difference to the answer. Like example, instead of south pole, if it was a north pole, but the diagram remains the same. If this is a north pole, then the south pole will be induced here and north pole will be induced here. And again, the like poles, what the like poles will do, they will repel. So these two north poles will move away from each other. In question 5, 4 nails A, B, C, and D are tested, which makes a strong permanent magnet. So 4 nails are there. Like example, first we place nail A. When we place nail A, when the magnet was placed, how many pins were there? 2 pins were there. But once the magnet is removed, like when we remove the magnet, no pin is attracted. So the one which is attracting more pins when there is no magnet around it, that is the strongest magnet. So when you check the option for B, what will happen when we place the B, like nail B is placed here, it was attracting 2 pins. This was not there, 2 pins. And once we remove the magnet, once the magnet is being removed, it is attracting only 1 paper clip. For C, what happened? First, initially, there were 4 pins when the magnet was placed. 4 paper clips were there. Once the magnet is removed, it is attracting 3 paper clips. So it means it remained magnetized and it's remain a strong magnet because it is attracting most number of the pins without the presence of the magnet. That's why C is the right answer. Is it clear, this one?
Yes, sir.
Any doubt in this? Okay. In which pair are both materials magnetic? Aluminium is a non-magnetic. It's a metal. All metals are not magnetic. So copper is also a non-magnetic. Copper, non-magnetic. Iron is a magnetic material. Iron and steel both are magnetic. Steel is a magnetic, but aluminium is a non-magnetic. So option C contain both magnetic material. That's why C is the valid answer. Which method could be used to demagnetize? This one is removed from the syllabus, the method of demagnetization. You just have the magnetic field. So we'll not discuss this question now. Question 8. Which diagram shows a direction? The compass needle always point in the direction of a magnetic field. And we know the direction of a magnetic field is from north to south. So this is a wrong direction. If you draw north to south, this is also a wrong direction. If you draw north to south, so this is a correct direction. If you draw north to south, this is a wrong direction. So C is the valid answer. In question 9, again, it's related to demagnetization. It's removed. And question 10 is also about demagnetization. In question 11, the diagram shows a magnetic field lines around a wire which is carrying the current. So when the wires are carrying the current, what we use a right-hand grip rule. So our right-hand grip rule is used to find the direction of a magnetic field. Which diagram is correct? So your thumb in a right-hand grip rule for a straight wire, your thumb represents the direction of the current. And your fingers will turn around in the direction of a magnetic field. So when you apply the rule for the first one, your thumb is pointing up and fingers are turning around. So this shows correct. When your thumb is pointing up, fingers, even this is wrong. Why? Because they are showing arrows in both direction, clockwise and anti-clockwise. This is totally wrong. When your thumb is pointing down, your fingers turn around. So this is the correct direction. When your thumb is pointing down, fingers will turn in this manner. So 4 is also wrong. So 1 and 3 are the correct position for the magnetic field lines. So using the right hand grip rule, you can work out the direction of magnetic field lines. In question 12, student wishes to use a magnetized coil to make a permanent magnet. So what is a permanent magnet? Aluminium and copper are the non-magnetic. Iron is a magnetic, but it's a soft magnetic, like it is a temporary magnet. But if you want to make a permanent magnet, so the permanent magnet, we use a steel. Question 13, straight wire carrying a current produces a magnetic field. Which diagram shows the correct shape of the field? Again, you have to use a right-hand grip rule. Your thumb will represent the direction of the current. And your fingers will turn around it in the direction of a magnetic field. So if the current is pointing down, the fingers will turn in this manner. This is wrong. If the current is pointing down, fingers will turn in this manner. So this is also wrong. Current is pointing down, fingers will turn around. So this is also wrong. Current is pointing down, fingers turn around. So D will be the right answer. Is it clear, this one? Question 13?
Yes.
Okay. In question 14, which metal could be used for a permanent and which could be used for the electromagnet or a temporary? So for a permanent magnet, we need a steel, and for a electromagnet or a temporary magnetic material, iron. Copper cannot be used because it's a non-magnetic material. It won't magnetize at all. An unmagnetized piece of a soft iron is placed close to a strong magnet. Always induced magnetism happen. So if this is a north pole, what pole will be here south and what pole will be here north? So the polarity of the pole on X, it will be a south, and the direction of the force, because it will be attracted, the soft iron will be attracted. So the direction of the force will be towards the left-hand side. So C will be the right answer. So these are 15 MCQs from topic 4.1, which is about the simple phenomena of the magnetism.